Alright, so section 4.5 is on a topic called completing the square, and basically this is another way of solving quadratic equations. Mostly you would use this when you cannot factor. Factoring tends to be the easiest, but if you can't factor, you can use completing the square. Okay. So 3 goals for this section. We want to answer the following 3 questions. What is a perfect square? How do you complete the square? How do you make a perfect square? And then how do you solve an equation by completing the square? So what's a perfect square? How do you do it? How do you complete the square? How do you solve an equation by completing the square? First thing is, what is a perfect square? We know what it is from numbers. These numbers that I'm writing right here are perfect squares. Okay, those are numbers that you get when you multiply something by itself. So that is 1 squared, that's 2 times 2, or 2 squared, that's 3 squared, that's 4 squared, 5 squared, and so on down the line. A perfect square, when you're talking about polynomials, which is basically a series of things with x being raised to different power. Perfect square is something that looks like this. If you take 2 terms, and the name for something with 2 terms is called a binomial. Bi means 2, like a bicycle has 2 wheels. Binomial has 2 terms. If you take that and you square it, squaring means multiplying by itself. And then you would FOIL this out. So x times x gives you x squared. X times 5 is 5x. 5 times x is also 5x. You'd have 5x plus another 5x would give you 10x. And then 5 times 5 gives you the 25. And you can see there are 3 perfect squares that we FOILed out here. The same thing here. If you FOIL out x plus 8 squared, you get this. If you FOIL out x minus 6 squared, you get this. Okay, so here is the pattern. Here's what a perfect square is. Okay, a perfect square has the following pattern. If you have something that you FOILed out like this, if you take half of that number right there, half of 10, you would get 5. If you square 5, you get this number right here. Same thing right here. If you take half of the 16, you take half of this middle number, half of 16 is 8. If you square 8, you get this number right here. Last one, just to verify, you take half of that number, half of negative 12, you get negative 6. If you square negative 6, you get that number right there. So the basic pattern is you take, in order to complete the square, in order to make a perfect square, this is the rule right here. Okay. You always take half of the middle term, half of the middle coefficient, that's the number attached to the x term, and you square it to get the last number. So half of 16 is 8, 8 squared is 64. Half of 10 is 5, 5 squared is 25. That's how you complete the square. So let's apply that to this right here. If we wanted to complete the square, we need to take half of these numbers here and square them. So half of 20 is 10, and 10 squared is 100, so 100 goes right there. Now if I wanted to write that as a perfect square, ask myself, what did I square to get that? Well, the key number, this number that goes right here, is half of this middle number, and it's what you squared to get 100, so that was the number 10. If you FOIL out x plus 10, you get this thing right here. Okay, let's keep that same pattern. So half of negative 6 would be negative 3. If you square negative 3, you get 9. So that now is a perfect square. And if we factor it, x minus 3, because minus 3 came from half of this middle number. That's how you factor it. And then the last one is a little bit tricky because there's not a nice even number like we had before. So we need to take half of 9, which is 4 1/2, or 9 halves, and then we have to square 9 halves. So 9 times 9 is 81, and 2 times 2 is 4. That's now a perfect square. And when we factor it, it's going to be x plus 9 over 2. Where did 9 over 2 came from? It came from half of that middle term right there. And those are now all factored as perfect squares. So that's how you complete the square. Okay, why is this useful to us? Because this brings us to our third goal. Now we can solve equations by using complete the square if we recognize the pattern. So if we look at this equation here, notice that half of 6 is 3, and 3 squared is 9. So we can recognize that that's a perfect square. Okay, what does that factor to? That factors to x plus, and half of that number was 3, so x plus 3 squared. You could verify that by FOILing it out, and you wind up back up here. So you want to solve that. That equals 36. Right now we can't subtract 3 because the x plus 3, that's like embedded under that squared sign. So we need to cancel out the squared sign by doing the opposite, which is square rooting. Whatever I do to one side, I have to do to the other. And there's two things you could square to get 36. You could square positive 6, or you could square negative 6. Both will give you 36. So to indicate that, what we do when we take square roots is we, in front of the square root, we put a plus or a minus, a positive or negative. Okay, so square rooting and squaring cancel each other out. And we could have x plus 3 equals positive square root of 36, so positive 6, because that's what the square root of 36 is. Or x plus 3 equals negative square root of 36, or negative 6. And now we subtract 3 from both sides. We get x equals 3 as one solution. Subtract 3 from this side, and we get x equals negative 9. And those are our two solutions, which we could check by plugging into the original equation. They both will equal 36. Alright, what if you don't have a nice number like 36 that you can easily take the square root of? So this one, for example, this is a perfect square. Notice that half of negative 10 is negative 5. Negative 5 squared is 25, so that is a perfect square, and it will factor the x minus 5. Where did the minus 5 came from? Minus 5 is half of negative 10. And now we apply the same method. We need to get rid of this squared, so we square root both sides. Square rooting and squaring cancel each other out. And we have x minus 5 equals, and remember, we put a plus or minus in front to indicate that there's two things you could square. Now here's the thing, 27 is not like 36, it's not a perfect square. But if you look at 27, there is a perfect square that you could pull out of it. 27, if you look at that list of perfect squares I just wrote, 27 happens to be 9 times 3, so square root of 27 is square root 9 times square root 3. The square root of 9 is 3, and then I still have that root 3, or that radical 3 there. So we could write this as plus or minus 3 root 3, and now we can solve like we did before. We're going to have two solutions here. X minus 5 equals positive 3 root 3, and x minus 5 is equal to negative 3 root 3. How do you solve it? You add 5 to both sides, and our final answer here will be 5 plus 3 root 3. Notice that you have to leave it like that. You can't say like 5 plus 3, this does not equal 8 root 3, that's wrong. Okay, and the reason why, these are not like terms. Imagine if somebody said 5 plus 3x, and they say, well, that's going to equal 8x. Clearly it doesn't, because these are not like terms. Okay, same thing here. 5 plus 3 is 8, and if you had 5 root 3 plus 3 root 3, then you could add them. But this one does not have a square root attached to it. That one does. So you can't combine them. You have to leave it like that. And then over here we do the same thing. So we're going to get 5 minus 3 root 3. Those are our two answers. Those are what's called exact answers. If you put those in a calculator, you get decimals, but in most cases it's better to leave them as exact answers, meaning that you don't actually calculate what the square root is. Okay, just one quick note. For most of these equations we're about to solve, you always want to put things in standard form. In those cases you didn't, because they were already perfect squares. Okay, but in general, standard form looks like this. It means your equation is equal to 0. So that's what we're going to do for these. Okay, let's try this one right here. Okay, so this is in standard form. It equals 0. We don't have to worry about that. This won't factor, so that's why we're using complete the square. Okay, and here's the thing. Normally for completing the square, let me actually go back a page so we can do this one first. Normally for completing the square, we need this number in front to be 1, which it is right now, so we don't have to do anything. In the next case we will. Okay, this will factor, so I'm just going to prove to you that this works both ways. We'll solve it by factoring and by completing the square. The next one will not factor, that one that we were just looking at. So I want to show you first that it gives you the same answer. So what does that equation factor to? We want numbers that multiply to negative 11 and add to positive 10. So one has to be positive, one has to be negative. What multiplies to 11? Only 11 times 1. And that would mean the 11 has to be positive, the 1 has to be negative. How do you solve this? How do you make it equal 0? Well, what number would you plug in here to make that parenthesis 0? It would have to be negative 11. What number plugged in here would make that 0? It would have to be positive 1. So there are those two solutions. Now let's do it by completing the square. Let's pretend that this did not factor and see what would happen then. Okay, so if it doesn't factor, that means this number is not working for us, so we would need to move it over because it's not working, it's not factoring. We have x squared plus 10x, and now that's equal to 11. I left that big space there so that we can complete the square. Remember, the pattern is you take half of this number, and half of 10 is 5. and then you square it, so you add 5 squared right here, you add 25, and then whenever I do to one side I have to do to the other. A lot of people forget to do that. They're so occupied with what's happening on the left side they forget about the right. Okay, this is now a perfect square. What did you square to get this? It's half of that number, x plus 5, the whole thing squared. And 11 plus 25 is 36. And now we're doing a problem like we did before. We square root both sides and put a plus or minus in front. Square rooting and squaring cancel each other out. And then positive square root of 36 is 6. And the negative of the square root of 36 is negative 6. And then we would subtract 5 from both sides. 6 minus 5 equals 1. And if we subtract 5 from both of these, negative 6 minus 5 is negative 11. So if you look at those two solutions, that's what we got back up here. So it just shows you that you get the same answer either way. Okay, what do you do if it doesn't factor? So this one is not going to factor. So again, this number is not working for us because it's not going to factor, so we're going to move it over. That's the first thing we want to do. 2x squared minus 7x equals negative 5. And here's the thing, we cannot complete the square unless this number here is 1x squared, and right now it's 2. How do you make it 1? You just divide by whatever number's in front. So we want to divide everything here by 2. I can't just divide that single thing by 2. I have to keep the equation balanced. So 2x squared divided by 2 is x squared. 7 over 2 is just 7 over 2. And we have that negative 5 over 2. Okay, how do we complete the square? Remember, it involves taking half of that middle number and squaring it. So we need to take half of negative 7 over 2. 1 half times negative 7 over 2. 1 times negative 7 is negative 7. 2 times 2 is 4. So this is the number that we're going to use, and we have to square that. So negative 7 over 4 squared. Negative 7 squared is 49, and 4 squared is 16. So that's what I need to add here, and that's what I need to add right here. This is now a perfect square. It's going to be x minus half of this number, which we said was negative 7 over 4. And then over here, we need a common denominator of 16, so I need to multiply 2 times 8, and that will be 16. And 5 times 8 is 40, so we have negative 40 plus 49 would be 9 over 16. And now we're at like the same stage as we were before, so we need to get rid of the squared by square rooting, so those cancel. And whatever I do to one side, I have to do to the other. In front of the square root is a plus or minus. And you can write the square root of 9 over 16. You can write it as square root of 9 over square root of 16. Square root of 9 is 3. Square root of 16 is 4. So that's the same thing as plus or minus 3 over 4. And now we can make two equations. We can say x minus 7 over 4 is positive 3 over 4. And x minus 7 over 4 is also negative 3 over 4. So let's add 7 over 4 to both sides. And when we do that, we're going to get x equals 10 over 4, which is the same as 5 over 2. That's one solution. And over here, when we add 7 over 4 to both sides, negative 3 over 4 plus 7 over 4 is the same as 4 over 4. And that just equals 1. So that is our final result. Okay, let's take a look at, let's do one more. Let's do this one right here. Because sometimes you don't get real number solutions, sometimes you get imaginary solutions. By the way, I just want to point out, we won't do this one, but on the other page, this number 2 right here would be done the same as the other ones. The only difference is you need this to be 0. So you have to subtract 8x from both sides and then solve it from there. We'll do this one right here just to show you what an imaginary solution looks like. So once again, this number is not working for us. There's nothing that multiplies to 22 and adds to 8, so we're going to move it over so that we can complete the square. And now I need to take half of this number, which is 4, and square it to put it right here. So that's going to be 16. Now I have to add that to both sides. This will factor. What number was half of 8? That was 4, so that goes right there. Negative 22 plus 16 would be negative 6. In order to cancel out that squared, I'm going to square root both sides and put a plus or minus in front. Those cancel. And then this is going to be, well, remember that from earlier with imaginary numbers when we were talking about it last section, negative 6 can be written like this. It can be written as 6 times negative 1. And another name for negative 1 is I. So I could write that as I times the square root of 6. So this becomes plus or minus I root 6. And then the very last step we can take here is we can subtract 4 from both sides. And so our final answer is going to be x equals negative 4 plus or minus I root 6. It's normal to put the number in front and then the root part second. And there's our two solutions. And that is section 4.5 we talked about what a perfect square is, how to complete the square, and how to solve an equation by completing the square.